So what I wanted to do, just a little extra information for you, was talk about how you can find the center of mass of an object if it has a uniform density and a uniform thickness. So this would usually apply to some sort of sheet of material that could have a thickness to it that we could actually break down into some recognizable geometric shapes and how we might do that. We wouldn't actually have to calculate the mass. So basically, let's say that we had some sort of scenario where, in our two-dimensional space, maybe we had a shape that was like a rectangle and then maybe a triangle, and it was all a single object, but I could break it down into two pieces, like the rectangle and the triangle. Now the idea is that maybe this is a sheet of steel and we know what the density is, and we can actually calculate the area because we know, like, this is some given height and this is the base, like base 1, and this is base 2. So we have some measurements to work with. So where normally our x center of mass would be equal to the mass of 1 times the position of that plus the mass of 2 times its position over the mass of 1 plus the mass of 2. You know, it might be a pain to try to figure out the mass of the blocks. We would be using the fact that the mass of either of those pieces would be equal to the density of the material times the volume that we have. And now in the situation where we have uniform thickness, we could write the volume as the cross-sectional area times the thickness. And we're assuming that T and rho are constant throughout the object. So if we substitute this into our expression for the x center of mass, instead of mass 1, we would say it was the density times area 1 times the thickness. So all of this would be m1, and then multiply it by x1. And then for the second piece, the triangle piece, it would be the density times the area of the triangle times its thickness. And so that is m2, and then times x2. And then, of course, we would repeat the values that allowed us to calculate the mass of piece number 1 and piece number 2 on the bottom. But notice that what's going to happen is that in every single term we have density, so we can actually cancel that out, and likewise we can cancel out the thickness. And so what happens is that instead of writing the position of the center of mass as a weighted average where it's weighted by the mass, it could actually be weighted by the area. And so this could be written as A1 x1 plus A2 x2 over A1 plus A2. All right, so that's some useful piece of information. So I wanted to just really quickly look at one of the problems from the back of the chapter and how we might approach it. So the one change that I'm going to make is we're just going to assume that this, instead of a three-dimensional sphere, I'm just going to say it's a disk. So that this person that we're looking at is being made up of a lot of individual pieces. And so if I wanted to find the position of the center of mass for this person, first of all, I gotta choose some place to put my x and y axis. So I'm gonna put the y-axis right down the middle, and the x-axis I'm gonna put at the bottom of his feet. So the idea here is, because I put the y-axis through the middle, I can say through symmetry that the y position of the center mass is going to be, that I should say the x position of the center of mass. The x position of the center mass is 0 because it's going to be somewhere along the y-axis. Now, so how am I going to find out what that y coordinate is? And it's going to be a lot going into this calculation, because I'm going to have to, basically, for each piece, I want to imagine what the y value of each piece's center of mass would be. Now, for all these, it's going to be at the geometric center of the individual piece. And the other thing that I'm going to have to remember is each one of these is going to have to be measured relative to the x-axis. So even though it's, the middle piece of his hand is 2.5 centimeters up from the bottom of the hand, its y coordinate actually isn't 2.5 because I have to take into account everything that falls below it, that brings it above the x-axis. So whatever this value is plus the 2.5. So there's a lot going on there. So the first thing I'm going to start with is the feet. And there are 2 feet there. So I'm just going to write the 2 because everything that, if I would calculate the y center of mass of this whole guy, I would have to have a term for the left foot and the right foot. So I'm just going to put 2 because they're going to be exactly the same values. Now the area, I'm going to put the area first. The area of that is 3 centimeters high and 8 centimeters wide. And then what is the position of the center of that foot? Well, measured from the bottom of the foot, it's 1.5 centimeters, and so that's 1.5. So remember that this was the area and this was the y value, and I multiplied it by 2 because there were 2 of them. Now I'm going to do the legs. Again, there's 2 of them. The area of the legs, they're 70 centimeters high and they're 8 centimeters wide. And then now the distance from the bottom of the leg to the top, of course, is 35 centimeters, but I have to add, to get the true y coordinate, I have to add 3 centimeters to get me down to the x-axis. So there's 3 centimeters to the top of the feet, and then I add 35 centimeters. So this is actually going to be 38. All right, now I got the body. There's only one of those. It's 60 centimeters high and it's 25 centimeters wide, so that's the area. Its center of mass is 30 centimeters from the bottom, but I have to add that 30 to 73 to get the total distance it is and to get its true y coordinate. So it's 30 plus 73, and so that is 103. Oops. And then I have the 2 arms, and I'm going to put a 2. Each arm is 60 centimeters long and 5 centimeters high, and the middle of that is 2.5 centimeters from the bottom, or I actually measured from the top 2.5 centimeters because I figured out that from the bottom of the feet to the top of the arms was actually 133 centimeters, and so this position of the middle of his arms would be 133 minus 2.5, so it's 130.5. And then finally, I have the 2 hands. It didn't really say, but they looked pretty square, so I just said that they were 5 times 5, and they had the same height, and I almost forgot the poor guy's head. which has an area of pi times 8 squared, and then the height of that would be, it's 133 centimeters to the top of his body, and then 8 more centimeters to the middle of his head. So it's 133 plus 8 is 141. And so all those terms added together go on the top. And then on the bottom, I would have the summation of all the areas. So that would be 2 times 3 times 8 were for the feet. 2 times 70 times 8 were for the legs. 60 times 25 was the body. 2 of the arms, 60 times 5. 2 hands, which were 5 times 5. And then the head, which was pi times 8 squared. And so that is how we would use the area to figure out the center of mass. And that's all the numbers that would go into the calculation. So I say go for it. See if you can figure it out.